Good day, eCognition fans. This is Keith Peterson, the product manager for our Trimble eCognition software, and I'd like to welcome you to our webinar today. This webinar is called eCognition for Beginners, and I think we're going to give you a very nice overview, first of all, of what the software is capable of, and then we'll move right into an exercise within eCognition Developer, and you'll see how this all works hands-on with our eCognition trainer, who is my guest today, Matthias Stengel. So first of all, overview of what we will cover in today's webinar, brief introduction, what is eCognition, some of its unique features for those of you that are not yet familiar with our software or maybe have forgotten what certain features are available within the software. We'll just do a quick overview. Then we'll jump right into our exercise on automated forest canopy extraction, looking at a fully automated workflow to extract forest canopy data information from imagery and point clouds in this case. And then we will wrap things up with an overview of what type of eCognition resources are available to you in the World Wide Web and beyond. And just to reassure you on how this webinar is working, everybody is in a listen-only mode. If you have questions, you can submit these at any time during the webinar via the questions field. And don't worry, this webinar is being recorded, so if you need to jump out at some point and miss a section, the recording will be made available shortly after we conclude the webinar in the Trimble Geospatial webinar archive. So let's get right into the introduction to eCognition. What is the eCognition software? First of all, we are going to be working with the eCognition Suite package, specifically using the developer software. And what we provide with eCognition Developer is an advanced analysis software and development environment. We think of this developer as a development platform, and this is primarily available for geospatial applications. What Developer does is it allows our users to create their own feature extraction and or change detection solutions to transform those geospatial data sets, whether it's going to be optical imagery, SAR imagery, or maybe elevation data as in a raster format, point cloud format, what have you. Transform these very nice data products into geospatial information, and by that I mean extracting out the information and putting it into, say, a land cover map, an impervious surface map, or maybe even looking at specific objects within our imagery, such as individual trees, manhole covers, something of this nature. This is what this software provides the tools to do. You can think of it as a toolbox for creating image analysis workflows, what we then call rule sets. The use cases, just brief here. We're about extracting information, but also about updating information. So we can take information from our imagery, create, for example, a vector file that then flows into our GIS workflows. But we can also take an existing GIS file, say a vector data set, and update that based on the newest flights that we have. So we're constantly getting new information. New satellites are always flying. We're getting imagery every day now from various satellite constellations. We have aerial campaigns going up. We have UAVs. So we're creating lots and lots of image information, and sometimes that outpaces the vector information that we have. So we don't have to create everything from scratch. We can update those existing vector files based on the new data and information that we have in our imagery. That being said, some of the unique features that are available within eCognition Developer, primarily we focus on what we call data fusion. What we mean by that is that we have the power to load not only raster data, so your imagery, into eCognition, but we can combine that in a project with vector data sets, shape files, file geodatabases, for example, and we can also combine everything with point cloud data, whether that's a photogrammetric point cloud or a LiDAR point cloud. That is, the source is irrelevant, just needs to be a LAS file or an LAZ file. And we can take these different data sources and we can fuse them together. We can combine them within a single project environment within eCognition Developer, and then allow these data sets to communicate with one another to create our our class descriptions, how we want to describe an object as it appears on the ground. And this allows us to create a much more robust classification result. That being said, I would like to move on to our exercise. Like I said, we're going to keep this introduction brief and really concentrate today on this exercise within the software. The software that we will be using again is the eCognition developer software. We are going to create a rule set today for automated forest canopy mapping. And I will now hand over the microphone to our trainer here in-house in Munich, and that is Matthias Stengel. Matthias, please let the viewers know what our goals are today, and then we can jump right into working in developer.
All right. Hello, everyone. Thank you, Keith, for the introduction. I hope you can see my screen now. The goal of today is that we're going to do an automatic extraction of forest canopies with crown height classes. So we first going to extract forest, and then we're going to go into the forest class and discriminate between different forest heights. And the data sets that we have is we have an aerial image, so RGB, and also a near infrared image. And additionally, we have a LiDAR point cloud data set, which we're going to also include in our analysis. So I already created a project that you hopefully see now. So I loaded the data. You see, it's actually a small subset. You don't see it yet. Now you see it, I guess. So I loaded the data into eCognition developer. And here you see RGB image of the subset that I created. And we also have a point cloud. Just going to display it for you. And we're going to use this information. We're going to fuse these two data sets together to extract our forested area. And I'm also going to show you this new cool feature here, the 3D subset selection of the point cloud. So you also can have a look in eCognition now. At your point cloud, you have a 3D view. So that really helps to check out your data sets. You also can change the point size. Let's go to large and inspect your data set, right? Okay, gonna close this here. This one as well. So as a first step, we're actually gonna transform our point cloud data set into a raster. And because we wanna use the raster data set in our segmentation. So I'm going to go to the process tree. This is where you develop your rule set, so your workflows within eCognition. I right click and can say append new. That's going to open this window here, and you can append a new process. In this case, you can choose here the algorithms that eCognition provides. That's quite a few algorithms. But in this case, I'm just going to give it a name here. So I'm going to give my rule set actually a structure with parent, so-called parent and child processes, which looks like a folder structure. And it really helps you to easily understand your rule set and to have a clear layout. It's also more transferable if you show it to a colleague or something. So first I'm going to give our rule set a name, and that's going to be forest classification. Leave all the rest empty, and I've created an empty process. Now I actually can insert a child, and you're going to see that this is going to be inserted into that forest classification. I'm going to call that preprocessing. In this step, actually, we will then take the point cloud data and rasterize it. To do so, again, right click onto this preprocessing folder here, say insert child, and now I'm actually going to choose an algorithm. So I'm going to look for rasterize point cloud. That's the name of the algorithm. Down here at the bottom, you have this point cloud algorithm. That's the first one, rasterize point cloud. Here, the only thing that I have to do is choose the point cloud. That's the name I gave the point cloud when I created the project. Then rasterize settings, point field. Here you can choose all the fields that are within the point cloud. In our case, we want to rasterize the set coordinate, so the height. I'm going to choose a kernel size of 3 and give the output layer a name. In our case, it's NDSM. So the point cloud was already normalized, so the elevation reflects the normalized digital surface model. And when I execute that, we will have created a new layer. I can check it in the image layer mixing. There was this button up here, and here you see all the layers that are within our project. And now you see down here, that's the layer that we've created. I'm gonna have a look at it. If it looks like expected. So what we did now is just rasterizing the point cloud based on the set coordinate. So these values here represent the height above the terrain. I'm gonna add another process here because I wanna smoothen a little bit the raster, and again, right click into the process tree. Gonna now choose append new, adding a new process, and I'm gonna use a median filter. So instead of unfolding here all the algorithms, if you know how the algorithm is called, you also can type in here the name and it will automatically filter the algorithms. So I'm going to look for median filter and run this over my newly created NDSM. That's the input layer. I leave the kernel size at 3. The output layer, I'm just going to overwrite my NDSM. And that's already it. And now when I execute it, if you pay attention here on the background, it looks really noisy. I'm going to execute this one, and now it's smoothened a bit more, right? And that was already the first pre-processing step. And afterwards, we're going to now start with the segmentation. So we need to create initial objects to start classifying, right? So we're working in an object-based image analysis environment, and that means that we need image objects to work with. So usually in the first step, you always create image objects, and then you can use the features of these image objects to classify them and extract information. So to keep a nice structure, again, gonna append a new process, leave the algorithm empty because I want to create a structural process. I'm going to call it segmentation. Hit OK. And I'm going to insert here our segmentation algorithm. So I right click on this segmentation, say insert child. That's going to insert a child process into this segmentation folder. And for creating image objects, we have here in the segmentation a few segmentation algorithms. I'm going to use the multi-resolution segmentation. That's the most widely used segmentation algorithm, and it's really creating really nice objects. And I'm not going to go into detail here. I'm just going to show you which settings I'm using, what they are doing. If you're more interested, you have different. He's going to talk about the resources in the end where you can get additional information about the algorithms and stuff like that. So what we're going to do, so we're going to use the multi-resolution segmentation. Here are the parameters on the right-hand side that can be altered for this algorithm. Now we're going to change the level name. I want to call it level 1. I always do that. So this generated image object level is called level 1. Then we can define the weights of the image layers. In my case, actually, I'm going to zero these out that I don't want to use in my segmentation. And I'm going to emphasize, you actually can increase the number here. I'm going to emphasize the NDSM, right? So you can actually play around here a little bit with the settings. It's always going to generate different image objects if you change parameters here. Then the scale parameter, that's more or less defining the size of your image objects. I'm going to leave that at 10. I'm going to change the shape and the compactness. This actually will create more compact objects. When you increase the compactness, you're going to have more compact objects. If you increase the shape, then the spectral information gets ignored more or less. So if you put a really high value into the shape, let's say 0.9, the spectral information is more or less ignored. So be very careful with the shape. But we're going to use these settings here. So scale parameter 10, shape 0.3, compactness 0.8, and we're using the multi-resolution segmentation. Now I execute this one, and that should create image objects. All right. So you see here the image objects that we've created with this process here. You also can see on the bottom right actually how many image objects we've created. So in this case, a little bit more than 28,000. Okay. I'm also gonna change the display here. So you see the aerial image in the background. It's still there, and you can overlay it with the image objects. All right. Now, after having created the image objects, we actually can derive features from the image objects. So when you click into an object, it's highlighted here in red. You can check the feature here in the image object information window. And to do so, you can go right click in here, go to select features to display. And there you have all the available features within eCognition. I'm just gonna go, for example, for the mean brightness, NDSM, near infrared, red. Geometry, we also can add the size in pixels and hit OK. And now when you click into these objects, you're gonna have the information of each single object displayed here. So this has a size of 97 pixels and NDSM is 21. So it's average height of this object is 21 meters. Whereas here we have 0. And this building here should have also an elevation 4.7 meters. We're going to use this information now to classify these image objects, right? So our goal is to classify forest. So how do we do that? We have our data sets, two of them, right? RGB and near, the aerial image and the point cloud. And what we did first was rasterizing the point cloud. And now we did a segmentation, so we created image objects. And now the question is how to classify forests. So I suggest as a first step, we're going to use the NDSM, so the elevation. And we're going to discriminate elevated and non-elevated image objects. And then in the next step, we're going to have a look at the elevated classification and then start to think about how to discriminate the elevated into forests and non-forests, okay? So let's go for the NDSM. So that makes sense. Forest has an elevation compared to grassland here or the roads. They all should have 0. And in forested areas, we have NDSM of 6.5, for example. So we're going to use this information to do a classification of elevated objects. That's the first step. Okay, so I'm going to again create such a structural process. Now we have preprocessing and segmentation. Next one is called classification. So I say append new and type in something here in the name, call it classification. I don't choose an algorithm, so it's more or less an empty process. Hit OK. That's the structural process. We again going to insert a structural process in here. Call it elevated objects. So I think this is very good practice to structure your rule set like this. It's very helpful if you, let's say, in 2 weeks, load your rule set into eCognition and you see a really nicely structured rule set instead of having only processes listed here. So it gets really confusing, actually. So please structure your rule sets, so it makes life easier. Okay, so we want to classify elevated objects based on the NDSM. And we're going to use an algorithm called assign class. This is going to assign a class to our image objects. And now a very important feature here is that here we define which algorithm we are going to use, and here we have the domain settings. And the domain defines where we're going to apply it. And the parameters here, they more or less define how. So the domain becomes now very important. So what we do at the moment, so we use assign class algorithm, which assigns a class to image objects. And in the domain, it says we're working on level 1. That's correct. That's the level that we've created in the multi-resolution segmentation. The class filter is none. That's also fine. We don't have a class yet. And in condition, we actually can now define a threshold that then classifies our image objects. So we only want to classify these image objects that are higher than 2 meters. You also could set a threshold of 1 meter, but I'm going to go for 2 meters, and all these image objects, I'm going to put them into a class called elevated. Okay. So in this condition window, we can choose a feature, and I'm going to find my feature that I want to use here in the object features, layer values, mean, and I'm going to go for the NDSM, which is the elevation, right? So I double click that one, and the operator is going to be larger equal to 2. So that reads all image objects that are larger than or higher than 2 meters or have a higher value of NDSM. And what do I want to do with them? I want to put them into a class. At the moment, it's unclassified because we don't have a class yet. So I'm just going to click OK for the moment, create a class, and go back to this process, and then choose the class here and execute it. So I hit OK. It's not executed yet, but it's there in my rule set. I'm going to create a class in the class hierarchy. So if you simply right click in here, say insert class, you give your class a name. In our case, it's elevated. You can choose a color for your class. I like this orange color for my elevated image objects. Hit OK. And now we have our first class in our class hierarchy. If I go now back into our process, I'm simply say use class elevated. So it now assigns a class to all image objects that fulfill this condition. So I have larger NDSM than 2, and they're going to be put into this class elevated. So let's see if something happens when I execute this. Yeah, nothing happened. So we have to change the view. So we're actually at the moment looking at the layer view. You can change the view here to classification. And there we go. We have a classification. So all image objects that fulfill these conditions are now classified as elevated. Okay. So that already makes me fairly happy. As a first step, that looks pretty good. But as you see here, we also have buildings in our elevated class, for example. So, and here as well. So the next step, I want to discriminate between buildings and forests. So how could we do that? So that's the classification hierarchy. We discriminate between non-elevated and elevated based on the NDSM, and we could do now, for example, discriminate forests and non-forests based on the NDVI, so the normalized difference vegetation index. And we have the formula here, near infrared. So as input data, we have near infrared layer, which is really cool if you want to classify vegetation, and the red layer. And we're going to create actually a customized feature which represents this algorithm and call it NDVI. So we can calculate the NDVI based on image objects within eCognition. And then we're going to use this feature to discriminate between forests and non-forests. Okay, so that's actually really cool. I need to remove my window here. So down here at the right, we have the feature view. I can drag it here into the center so you see it. And if you go to object features, customized, you actually have chance to say create new arithmetic feature. That's actually what we need to create this NDVI. Okay. If you double click that, you can first of all define a name for your arithmetic feature. I'm going to go for NDVI, and then you can input the formula here. You can use any features that are provided here and these operators. So I'm going to simply insert that formula. I'm going to use the object features near infrared minus red and divide that near plus red. Okay, so that's a well-known formula, and that's going to calculate the NDVI, which really helps us to discriminate then between vegetation and non-vegetated areas. I click OK, and you see here we're going to have this new customized feature called NDVI. And we're going to use that now to discriminate between forests and non-forests. All right, so I'm going to put that back the other side. So where is it? Like that. So I'm going to add a new structural process here. Going to call it forests, because we're now going to look at forests. And all right, I see we have questions here. Oh, Keith, do we have questions? I see a few here in the chat.
Hi, Matthias. Yeah, we have a few questions here. One I've answered to the group already, but if anybody had missed this in the question dialogue, we had a question earlier regarding segmentation, whether it's possible to use just a single layer within segmentation, or do you always have to use multiple layers within segmentation? The answer is yes, you can base your segmentation off of purely a single layer, even within the multi-resolution segmentation algorithm, but you can also use additional algorithms, segmentation algorithms available, and base them off of a single layer. A second question came in here, and I'll hand the mic back over to Matthias to answer this one, regarding ways to discriminate between image objects. And the question is, can we use an object shape parameter to differentiate between image objects? And they're talking about, say, I'm looking for more triangular shapes or rectangular shapes. Is this possible within eCognition?
All right, thank you for the question. That's actually more or less a core feature of eCognition, because it's using this object-based image analysis methodology. And if you have a look at a feature view, you also have this geometry folder here. And here you can address, let's say, the shape of image objects. There are a few predefined features that you can use: density, compactness, elliptic fit, roundness, rectangular fit. So you actually can use the shape of image objects for classification as well. And that is really helpful if you, for example, have image objects that have the same spectral signature, for example, a roof of a house and the road, but the image objects created for roads, they are more lengthy. So you can use the shape to discriminate then between house, which is more rectangular or has this rectangular fit, and the road, which is very lengthy. So very good question. That's a really cool feature in eCognition to address the shape of image objects. Okay. So again, add class hierarchy, gonna add it down here. Okay, let's go back to the classification, right? So we want to classify forest based on the NDVI. So we're gonna again use this algorithm called assign class and use the domain again. So right now we only want to look at elevated image objects. So we don't want to have a look at a unclassified image object, only the elevated. And as condition, we say, all right, if you have a higher NDVI, then I'm gonna go for a very small value, I think 0.01 or something. If you're larger than that, you're gonna be put into my class forest. And that's just a shortcut that I'm gonna show you now. So instead of going into the class hierarchy, you also can type the name in here if you haven't created the class yet. Forest in this case, and then this window is gonna pop up, the class description window. I'm gonna give the forest a very bright green color, hit OK, and say execute. And now we only classified these elevated image objects that have a high NDVI into the class forest. And you see that most of the buildings are still classified as elevated objects and not as forest. So that's really cool. I'm gonna add another assign class algorithm to just kick these elevated objects into the class and classify it. So I'm just cleaning up a little bit. You actually also can use here in the process tree Control C and Control V for copy and paste. That also makes rule set development faster and easier. And in this case, I'm gonna delete that condition, and all elevated objects that are left over I will put into the class unclassified. So, because we're only interested in forest, so I'm just cleaning up my classification. All right, so that looks good. But we're gonna improve actually this classification. You see it, these holes, we're gonna get rid of these holes in next step. Usually that's called refinement. So we're gonna refine the outlines of our image objects and improve the classification. So what I'm gonna do is it's gonna fill up these small holes here, and we're also gonna refine the outline of our image objects. And we're also gonna reduce the number of image objects that we have in our project. So I'm gonna close these structural processes. That's also very handy if you have a nice structure in your rule set. And we're gonna start with the refinement. And as first step in the refinement, we're gonna actually merge all forest objects together and also the unclassified. So this is more or less like a dissolve in GIS. So we merge these image objects together and then work with these merged image objects afterwards. So refinement merge, I'm gonna insert a child here. That algorithm is called merge region. And now the only thing that we have to do is to set a class filter. So we wanna first merge our class forests. I'm gonna display the outline so you see what happens. So you see we have a lot of image objects here for the class forest, even though they're touching. So we're gonna clean up this one, and it's gonna be a big object after executing this one. And you're also gonna see that the number of image objects is, hopefully will decrease from 28,000, okay? So I'm executing forests, boom. That's the result of that one. And we're gonna add another one to actually merge the unclassified image objects. Okay, that looks good. And we only have 420 objects left. And in the next step, we're actually going to take care of the boundary. So we're going to smooth the boundary a little bit, and we're going to use actually my favorite algorithm within eCognition called pixel-based object resizing. So I'm going to again create a new structural process and call it reshape, because I'm going to add reshaping algorithms here into this folder. And we're going to look for pixel-based object resizing. And this is really cool. You can actually grow, shrink, or code your image objects. And you can also define which objects you want to grow, right? So in our case, I want to grow forests, right? So, okay. And let's see, we have questions, but I'm going to finish this algorithm afterwards. I'm going to hand over to Keith, who has more questions. You can add different constraints. We actually, on this algorithm, pixel-based object resizing, we also have a video on YouTube. Let's see if I have it there. Here we go. So that's our eCognition deconstructed series, started this year. So we're going to put out each month a video, and you have actually 2 videos on this pixel-based object resizing algorithm. So if you have questions, also if you don't understand what I'm doing here, you can go there, and afterwards you're going to understand it. There are very nice examples in these videos. Okay, and also in the videos, I also explain candidate surface tension that we're going to use now. I'm just gonna choose these settings, so this is gonna grow. These settings will actually fill up these gaps in here. So it's gonna smoothen the outline. The goal is to have more or less a straight line here, and it will fill up these ones here, right? Also this one should vanish based on these settings. So, and I almost forgot that, I'm gonna set the number of cycles to 3. So it's gonna do the same process 3 times in a row. Gonna execute that. And you saw it actually filled these gaps. Okay. All right. Before we continue, Keith, I'm gonna hand over to you. You have some questions, right?
Yes, a few questions have come in now. The crowd seems to be warming up. One question that we have here is regarding the rasterized point cloud algorithm. And here we use that rasterized point cloud algorithm to create our NDSM layer because this point cloud was a normalized point cloud to begin with. The question is, when we rasterize the point cloud, what is then the resolution? What is that raster cell size that within the raster file that we create within eCognition?
All right, so the size is defined by the project pixel size. In my case, if I go to modify open project, in this dialog, I loaded a raster layer, which has a resolution here that you see here of 0.6 meters. So this is going to be the pixel size of your project. And if you apply this algorithm, it also generates a raster file with a pixel size of 0.6 meters in this case. Okay, are there more questions?
One question also came in. Let's say we don't have elevation data available to us, no LiDAR file, maybe no DTM, DSM to begin with. How could we use this then to differentiate between forest, which would then be our elevated vegetation in this case, and grassland? And one way that I've seen in the past, and Matthias, you can also speak to this in just a moment, is to use a simple texture. Forest is a much more textured object, whereas grassland, if you look also in this image, we see some of these grasslands in comparison to the forest, they are much smoother texture. So we can use something as simple as a standard deviation to describe, start to differentiate between forest and grassland. Will it be as, say, robust as the height difference? It will depend on the operating environment that you are. But this is one method that I can think of off the top of my head that could be used here. Matthias, do you have maybe any other ideas that you've used in the past?
Actually, that would have been my approach as well, but you also could use actually the shadow. That was also an approach that I used for a project that I did. So elevated objects, also in this case, you see have a shadow, right? And in eCognition, you also can use these context features. So you could say, for example, if my object is now classified as vegetation and it has adjacent a shadow or very dark area, then it must be elevated. So that could also be used for discriminating between elevated vegetation and grassland, for example, right? But first I would go for the texture as well. That's a good approach. Okay, so I think we're gonna continue. What we did was using this pixel-based object resizing mode growing. So we filled gaps, and in a second step, I'm going to use shrinking. I'm going to turn this operation around. Please, again, just check the videos after this webinar, and everything that I said here is going to be explained in detail. But that's going to remove all these outreaching peaks here, right, and smoothen the outline further. What did I do? I didn't hit OK. All right, so again, shrinking. I changed it. All right, and I execute this one. Now you see we removed all these outreaching peaks, and in the final step, I simply, because the shrinking generated these small image objects, right? These unclassified now, that these were removed in the shrinking process from the forest. So I'm simply gonna merge them again. And what I did, I just copied this merge process and pasted it down here. So that's very fast rooster development. Yeah, that's because I have to speed up to be able to finish these rosets. So, right, so we did a reshaping. Still, I told you before that I'm going to take care of these holes here. We're going to do that now. So we're actually going to address the shape of image objects in this case, and also the context. So we're going to use again assign class and say, all right, if you're an unclassified image object and you're fairly small, in my case, I'm going to choose, I guess, 600 pixels. So if you're smaller than 600 pixels and you're 100% surrounded by forest, you're also forest, right? So that's just my definition. It will look way nicer afterwards. So let's go ahead and create this process. So I'm gonna create a new structural process again, call it improve classification. Okay, and I'm gonna insert a child, in this case, again, assign class. So it's a very simple algorithm, but very powerful, because you can have all these conditions defined here, class filters and stuff. So it's a really cool algorithm. And first condition is gonna be the area. So let's have a look at only image objects that are smaller than 600 pixels. So I'm going to go to Object Features, Geometry, Extend Area. And I'm going to say smaller than 600. And here add new, you can actually add multiple conditions. You also have the chance to connect them with AND or OR. So you can become very fancy here. The second condition in our case, we're just going to have two. One is area, so small, and the other one is going to be 100% surrounded by the forest class. And this feature is going to be here in the class related features, and you're going to find here relations to neighbor objects. If you unfold this one, you have this relative border 2, and that calculates actually the relative border of the object to, let's say, the class forest. Hit OK. Going to use this one, and if this equals 1, so if it's 100% surrounded by forest and smaller than 600 pixels, all right, it's gonna be classified as forest. And the class field, I'm only looking at unclassified image objects. So we're gonna assign a class to all unclassified image objects that fulfill these two conditions, smaller than 600 pixels and relative border to forest 1, they're going to be put into the class forest. Let's execute that one. All right, nice. That looks good. So all these objects are now classified as forest. In the next step, I'm simply going to merge them together, right? So this becomes one big image object again. I'm going to search for my merge region process here. I'm just going to Control-C, copy that one, paste it here, and I'm going to execute it down here. And now we already have a very nice forest mask. One last step in the refinement is going to be the removal of small forest objects, because my personal definition is that a forest is only forest if it's larger than 200 pixels. Okay, and I'm going to use to remove these image objects that are classified as forest, I'm going to use an algorithm called remove objects. I'm going to append a new process, call it, and I'm going to look for remove. Let's say remove objects. That's it. And what I want to do is in the class filter, I'm only want to remove forest, right? I'm going to look, we are looking at a forest class, and the condition is now we again going to choose, look for the area. So geometry extend area. And if that forest object is smaller or equal to 200 pixels, that's the unit, it's gonna dissolve into its surrounding class, more or less, okay? You have further parameters here, we're gonna leave that default. And when I execute that, all these small objects should vanish. All right, they are gone. So now the smallest image object classified as forest is 201 pixels, okay? And that already looks pretty nice, I would say. So let's check our classification for the forest. We have this option here to split our view. I really love to use that to check if my classification is good or not good. And we have this swipe view. And now you can change the view settings in each pane. I'm just going to display here our aerial image and down here the classification and use the swipe tool. And that looks, it's not perfect, right? But it looks all right. So I'm happy with it. That looks good. Okay. So we're actually done with the forest classification. But our objectives were that we also discriminate into different height classes, right? So that's going to be our last step. We did, this is our classification tree, more or less. We split it at the beginning, elevated, non-elevated, based on the NDSM, so on the elevation of the features. Then we calculated the NDVI to discriminate between more or less houses and vegetation. And in the last step, we're going to discriminate different height classes within the class forest. And we again, of course, going to use the NDSM. And we're going to discriminate into these 5 classes. It's lower than 5 meters, 5 to 10, 10 to 15, 15 to 20, and higher than 20 meters. And I'm going to show you a very nice algorithm called multi-threshold segmentation, which does that in one step. So let's go for the last steps. I'm going to add a new structural process, call it classification 2. Classification 2. And I'm going to insert a child and I'm looking for a segmentation algorithm called multi-threshold segmentation. Now we're going to work, instead of when we use the multi-resolution segmentation, we're in domain pixel level, but we already have an image object level and we want to only do a segmentation within our forest class. So we're going to choose here image object level. And then here we can set as class filter our class forest. And now the segmentation only will take place in the class forests. And now there was also a question in the beginning, right? In this case, this algorithm also only allows to use one layer. And we're going to use the NDSM, right? So we're going to do the multi-threshold segmentation only on one layer. We also can define a minimum object size that is generated. I'm going to go for 25. So we do not have image objects that are just 1 pixel in size. And then down here, we have the different thresholds that we set. So the first threshold is going to be 5 meters, okay? The second one, 10, then 15, then 20. And now how you read that? So class 1, all image objects that fall under the threshold of 5 going to be classified as, in our case, smaller than 5 meters. Okay. gonna give that class a dark green color. Hit OK. And then next one, it's a threshold 5, between 5 and 10. All these image objects going to be classified into the class 5 to 10 meters. Okay. Let's give that also green color. Then 10 to 15. So it has to be in ascending order, right? These thresholds. And that one is 15 to 20 meters. And let's go bright. And the brightest class gonna be higher than 20 meters. Okay, so larger than 20 meters. Gonna give it a very bright color. It's that's very bright, or something like that. Okay, and now when I execute that one, it's gonna split my forest object into these different classes based on solely the NDSM. Okay, so that's a really cool way to do a segmentation and classification in one step. Let's execute that, and that's the result. So what you see is that we split up our forest class into different canopy heights. Okay, let's undisplay the outline. And then that was just one line of, that was just one process within eCognition. And that's our final goal. So we did actually create, so that was our game plan, starting with the data, discriminating elevated, non-elevated, then forest, non-forest, and then splitting this forest class up into different classes, different height classes. And the final step would be the export. So I'm going to create a new structural process here, then insert a child. And if you look for export, you have a lot of different export algorithms. You can export rasters, screenshots, statistics, and also point clouds, or whatever. In this case, we're going to export vector layer. And here you can choose, for example, shape type, points, polygons, lines. In our case, polygons would make sense. And what else? You can define the name, of course, and also the attributes that you want to export. So you can choose any attributes, as many as you want here from the list. Okay, mean, let's export that one. Okay, and executing this will produce a shapefile that you then can use in another GIS system or something, or you could export raster, and that would be your final result here. Okay, what I did here was I created first a subset. I also applied it on the whole image. So I took that rule set and applied it on the whole image and classified my whole scene. So it also makes sense to develop your rule set in a small subset, so everything is very fast, and afterwards go to your larger data set and execute your rule set there. And the result looks really cool. Okay, so that's all I wanted to show. Peter, I think it's time for you to take over, right, for the last part of the presentation.
Just have a few more questions that came in, Matthias. One is from our group of listeners in Latin America. They were just asking if you could just review those chapters of the rule set that you created. Just do a basic review of what each one of these chapters was dedicated to without going into too much detail, and executing them. Again, just review what we were trying to do within each chapter of that rule set that you created.
Okay, so I'm just going to delete everything here again. What we did in the first part was simply rasterizing our point cloud, because I want to use this information into the segmentation process. Therefore, I created a raster based on the elevation information of the point cloud. That was done here, the raster creation. And then that's actually the principal workflow in eCognition, that you do a segmentation, classification, you refine your image objects, and then you export your results, right? Segmentation, we use the multi-resolution segmentation. You can play around with the settings. I want to have more compact objects. That's why I increased the compactness here. You also could create smaller image objects or larger ones. It depends on the purpose of your classification and what you want to have, right? Then the classification was first discriminating elevated and non-elevated objects based on the NDSM information. I'm going to execute them. So you see, also see what I'm talking about. So first one was creating new image objects. Then these are all unclassified. I classified the elevated ones here now in orange. Then in the next step, I discriminated forests and buildings that are both elevated based on the NDVI that we calculated as a customized feature. Then I started with the refinement. First was merging. So I have a lot of image objects here that I don't need, in my case, for the refinement. So I merged them together, right? That was first step. Then reshaping was taking care of this outline, right? So let's have a detailed look at this outline, and I'm gonna execute the whole thing. That's also an advantage of structuring the rule set, right? You can now execute this folder, and it's gonna execute all the processes that are stored within this reshape folder step by step. So that's very helpful as well. So take a look at the line here, forest outline. I want to smooth it, improve it, and that's the result of my reshape procedures. Then finally, I removed or I included these small gaps in the forest into the class forest, and also removed very small forested areas. I actually don't know what the definition of forest is based on the size, or if 2 trees are already forests. I don't think so. So I applied this one for improvement. So we filled the gaps and removed small forest objects. And then finally, classification 2 is simply looking at a class forest and discriminating based on heights into different height classes of the forest. And I use the multi-threshold segmentation to do so. I'm going to execute that, and you're going to end up with something like this. So we have here the class higher than 20 meters. Here it's lower than 5 meters, right? Solely based on one layer, the NDSM that we've calculated based on the point cloud data set that we've loaded. And usually as a last step, you want to export your results to show it as a raster, the classification or shapefile, or statistics, the area of classified forest, project statistics, and stuff like that. So that's usually the last step to export your results. Okay, Keith, other questions?
So getting a few questions that keep on coming in here. One that came in is we saw the referenced in the object domains and stuff was this concept of levels. What are these levels and how do they correspond to image objects? So when we create image objects in eCognition through, say, a segmentation, these objects need to be stored somewhere, and we store these objects in what we call an image object level. And image object levels, for example, can very simply be used to store our image objects at various steps within our rule set. So if we're in development and we want to experiment and we create our initial segmentation, we then want to do a classification, but I don't want to necessarily overwrite the initial image objects that I have with this classification. I can create an image object level and then do my classification in a particular image object level without affecting the objects in that initial level. That would probably be the most simple example of where we can use image object levels. If we go beyond that, we can store objects that represent maybe various stages of a class or different classifications. For example, when we're working multi-temporally, we can store the different multi-temporal classification results in different levels, and then we can communicate between the objects in those levels. And by this, we can compare the object at level that maybe 2010 to the object that it's now in its current state in 2018. And if we see a change in the classification, then we can identify that object as having a change that occurred at some point during that time period. So there are many different ways you can use levels within your rule set. Another question came in here is, can you use eCognition to leverage training data? By this, I think what is meant, can we train eCognition based on an outside source, a training data source? Let's say maybe you have GPS ground truth of a certain land cover. Can you use this data to train a classifier within eCognition? Again, let me just answer some of these questions. So what we've seen in this webinar is an example of what we call knowledge-based classification. The developer, in this case Matthias, he is defining the class definitions based on his expert knowledge of remote sensing of this particular image, of the classification results that are desired. It is also possible to do supervised classification within eCognition, which then would require such training data sets, and these training data sets can be created fully within eCognition. You can also import training data sets from a shapefile source to use in eCognition to train that classifier model on what to look for. Another question here. Can you expand the rule set so I can get a screenshot? One viewer is asking. Yes, Matthias, feel free to expand the rule set. You can definitely take a screenshot. Do remember though, the webinar is recorded, so you can go back and reference this at any time you like after the fact, and it will be available on the Trimble Geospatial webinar archive. So you can, if you miss something, if we went a little too fast somewhere, don't worry, you can go back and reference the recording to get those answers. Let's see, another question came in here. Can I perform accuracy assessment for a classified image from a different image levels? There are accuracy assessment tools available within eCognition Developer. For this, I think we're going to talk about the resources in just a few moments. I can point you to the direction of where you can find a tutorial that will cover accuracy assessment within eCognition, and that will definitely show you how to do this. You'll get demonstration data, rule sets that you can use to base your work off of. So I'm going to now take back over the role of presenter here, and I will show the last few slides we have in today's webinar based on our eCognition resources. So again, this webinar has covered a lot of material, especially the exercise, a lot of nice algorithms being touched upon. Where do I go maybe from here if I'm a new eCognition user? Where can I get more information to speed up the learning process of this software? So we have a number of different resources available. There are guided tours and tutorials, YouTube videos that Matthias has already mentioned, of course, our webinar series, and we also have several blogs that can be subscribed to. And all of this is free material for you to use in learning, and you can reference these as often as you want. And you can also use the blogs to communicate with us if you have questions. Guided tours and tutorials, these are hosted in the eCognition community. Again, this is a free user community. I believe we're over 15,000 registered accounts in this community. So it's a great place for dialogue, exchange, asking questions with other users, with our staff, of course, that are active in the community. You have 3 guided tours. These will introduce you to various functionality within eCognition. One looks at an example of what we call simple building extraction. We then have one that looks at impervious surface mapping, and then more advanced techniques for building extraction. Don't think about these as a way of finding out how to do it necessarily a specific task, but you will also see general workflows covered here, so you can get a better understanding of how rule sets are created and managed within the software. In addition, we have 7 tutorials available within the eCognition community. Here, everything from working with regions or maps. These are concepts that will be introduced within the tutorial. So if they're foreign now, please go to these tutorials. You can simply search tutorials within the eCognition community and go through the listing here. We have analyzing regions of interest, working with LiDAR data, and also here again using sample statistics. This is again that exercise that will also look at the accuracy assessment within eCognition. Also, something that's very interesting and new in eCognition 9.3 is deep learning. There are tools for conducting deep learning. We use the Google TensorFlow system within eCognition, and you will find tutorials of how to work in deep learning to work through this without having to get bogged down and say programming all that Python script yourself. In addition, then working with point cloud. So if there are more of you interested in specific point cloud questions, I would encourage you to take a look at that tutorial as well. All of the tutorials come with step-by-step PDFs as well as data to work on. Yes, the YouTube channel. So if Trimble Geospatial has a YouTube channel, within that there is a specific section for eCognition. This is where we host our eCognition deconstructed videos. We, since the beginning of the year, have been publishing a monthly video. These focus on specific algorithms. Some of them, like Matthias said, are broken up into 2 parts. We try and keep this under 15 minutes. So you can go in and subscribe to this. You all then get the latest video. So you can see we've covered multi-threshold segmentation. We've covered the pixel-based object resizing algorithm, layer arithmetics. Cutting out shapefiles, I believe, is also a video here. So just stay tuned here, and you'll get the tips and tricks. Not only how do the parameters work within an algorithm, but we also show use cases. How could you use this in the real world? We also have some blogs, and these are in the form of the eCognition group. This is hosted in LinkedIn at the moment. We have, as a part of this LinkedIn group, we have what we call the eCognition Brainwave. This is a weekly tip that we put out, and these are pretty specific to solving and maybe making life easier in certain areas. So please, again, you can sign up to this group. It's free. You then get all this information. You also get notified via the group of news and what we call hot topics, what's going on with the eCognition team, and whatnot within this group, and again, free for all to use. Beyond this, we also have case studies. There's a whole host of case studies. So if you're looking for more examples of how eCognition has been used by other folks out there, maybe inspiration how your organization can also leverage eCognition, you can access these in the Trimble Geospatial Customer Stories portal. Here's the address. You can download these PDF documents and read through the highlights of what's going on with other eCognition users out and around the world. Yes, we have the webinar series, as you are fully aware if you're attending this. This is through the Trimble Geospatial webinar portal. You'll see a number of Trimble topics covered here, not just eCognition. You also see things like Trimble Business Center also does a pretty frequent monthly webinar, power hours, things of that. So we have 3 different general categories here. Starting point, like today, where we're introducing some new topics to newer users, if you will. We have a section on Elevate Your Skills here. We are also hearing how some of our partners use eCognition. You'll see a whole bunch of these within our our webinar series. And we also have the Power Hour, where we really tackle maybe some complex specific topics within eCognition. So we've been touching upon something in each category. We typically try and do this once a month. So you'll see these notifications, and again, it's free. You can just sign up and register, attend live, or then access the recordings afterwards. And I said, maybe finally, just before we wrap up, I will field a few more questions that have come in the meantime. But other eCognition resources, we have eCognition training. And we have several upcoming training events in the calendar this year. We have an open training event that will be taking place in Berkeley, California. Here, this date has been finalized. It will be between August 14th and 16th. If you have the energy and the interest to attend this event, it will be a very good several days, really getting your hands into eCognition, also interacting directly with our trainer, Matthias, and getting all those questions answered in all the detail you like. For European customers, we have a training coming up, or we're currently scheduling this in the UK. This will take place at some point in early September 2018. At the moment, we're still working to finalize the location and date for that, and we will make the notifications of this once everything is completely final. So, can take a few more minutes to answer some of the questions that have come in here. Let's see what we have. One question: what is the automation capability of this process? So in this webinar, we created a rule set, and I think at the very end of it, Matthias showed very nicely. He then took this rule set that was maybe developed on a subset of the data, which is very efficient. You don't have to wait for large data sets to process. But we then transferred this to the entire image, or to an entire stack of images. So the automation capabilities of the process will depend on several factors. How much automation you want within the project, it's flexible here, and how much automation is even possible to solve a problem. Not every image analysis problem can be fully automated, but we can provide a wide range of semi-automation to this particular algorithm. This process that we created, this rule set, this will run completely automatically. All we have to do is bring in the next image from this mosaic and click execute, and it will then automatically run on this. Or even better, we bring in a whole series of images from our mosaic, and we queue these up in eCognition server and send them in batch for processing. Let's see what else came in here during the meantime. Is there an archive of rule sets developed by other users which can be used as a starting point or examples to look at? Excellent question. Yes, there are rule sets available. Again, the eCognition community is a great place to start looking here. You will see the rule set files. These are stored as DCP files. You can download these. Some of the rule sets have been uploaded by users, some of them by our eCognition engineers, and you are free to use any rule set in the community for your needs. Take note, though, that these rule sets were developed maybe on a particular set of imagery. So a rule set that was developed based on Landsat may not work one-to-one on Sentinel data. So you may get the rough outline of what you want to do with the rule set, and then just adjust the parameters to meet the needs of your data. So yes, there are pieces like this available out there. So that being said, I'd like to move on to our final slide here, and just thank you for attending this webinar. We went a little bit over the 1 hour, so thank you for bearing with me and with Matthias. Again, my name is Keith Peterson. I'm the product manager here at eCognition. Matthias is our technical support engineer, or one of our technical support engineers. And I would say, if you have any questions that we just didn't get to in this webinar due to time, please feel free to contact us at support@ecognition.com, and our engineers will get back to you and answer that question. So thank you for attending today. I hope you enjoyed this webinar, and stay tuned for our upcoming webinars next month, and also any events that we have coming up in the next month. If anybody will be attending the GeoBia 2018 in Montpellier, France, our staff will be there as well, so you can also approach us at the GeoBia, where we will also be conducting mini hackathons, and you can approach us, and we will try and solve your problem within the allotted time at the GeoBia. So another great opportunity that's coming up to mingle with our engineers and myself for this. So again, thank you for attending, and we will see you next time.